All right, silly people, here's the situation. We're going to be doing a computation of the Madelung constant for sodium chloride. Um, and that's a lot of text, but basically it comes down to you have a lattice of sodium and chloride. The sodium is a positive ion, the chlorine, I guess, is a negative ion. And they are in a lattice where they alternate positive, negative, all throughout the whole lattice. Um, and so to calculate the Madelung constant, um, you need to first of all calculate V of ijk, that is the electric potential uh, between the lattice point that you're at to the origin. Um, and that's given by this formula because it is just an electric potential. Um, but then you sum over all ijk for that, and then that is equal to a bunch of physical constants times the Madelung constant. Now, uh, what we're actually going to do is because the m is equal to, it's given by that equation, all I did was I rearranged it so that m equals 4 pi epsilon naught a over e times v total, and then use the fact that v total is just the sum over ijk for this stuff, and then notice that the leading constant inside of the sum is the inverse of the leading constant outside the sum, so you can cancel those out. So we're literally just taking the sum of minus 1 to the I plus j plus k over the square root of I squared plus j squared plus k squared, um, excluding the origin point, right? So um, since this is in the for loop section of the book, I assumed that he wanted us to do this with for loops. Um, and so for that solution, I had to get a little bit creative because if you start with like an L equals 10 and just try to do your regular for loop for I in range 10, notice that it only prints out positive values and only prints out 0 to 9. So actually, you want it to, first of all, be added by 1. That way it also counts the last one. So you actually get I equals 10. And also, we're going to multiply it by 2 inside the range function, and then subtract L inside the print statement. So that way it prints out negative values first, right? And then it goes all the way until the positive value for L. That's the solution that I went with. You might find a different solution, but that is what I found. So doing this in 3 dimensions, though, we're going to call this quantity, this lowercase I minus L, just capital I, and then also do the same thing for J, 2 times L plus 1. Oh, whoops, I didn't mean to run the dang program. And then J equals J minus L plus, or whoops, it's just J minus L. Yes. And then for lowercase k in range, 2 times L plus 1. And then capital K is going to be K minus capital L, right? Then we don't add anything if I equals J equals K equals 0, so we're going to have to create a couple of if statements. If I equals 0 and J equals 0 and K equals 0, it's not the prettiest Boolean I've ever written, but if those are the case, then you don't do anything. So I'm just going to write m plus equals 0, and I just realized that I should probably define the variable m. You start with 0, and then you add everything up. So yeah, if that's the case, then don't do anything. Then the next if statement, if it's even, you add 1. If it's odd, you subtract 1. So let's do elif I plus j plus, and actually just realized that these should all be capital I's, capital J's, and capital K's to stay consistent with our notation. And then if I plus j plus k percent sign 2, that means it's going to divide it by 2 and get the remainder. And if the remainder is 0, that means it's even, and therefore you add on the actual Madelung constant, which was 1 over the square root of I squared plus j squared plus k squared. We have access to NumPy now, so I'm just going to import all of it as NP and then use the square root method. I guess it's a function, the square root function of it. And then take the square root of I squared plus j squared plus k squared, right? Finally, if the sum of I plus j plus k gives an odd number, we'll have it do m minus equals 1 over the square root of I squared plus j squared plus k squared. And then we'll have it print out the Madelung constant after everything. I'll say that on my computer, the closest I got to having it run in an entire minute was with L equals 147. Might be different for you, but I'm going to give this a go. And it gets us minus 1.75, which matches the value that I found on Wikipedia for this. So I think our code worked just fine, and that ran in 56.476 seconds. Fun stuff.